Fortunately, the team which develops and maintains our applications, which you use, is at a higher level. I will not go through the details. You can quickly read this. These slides will be on the thing. You can read the various levels. For example, the level 2 is called a repeatable level, because the basic management processes are established, cost, schedule and functionality is tracked, discipline to successfully repeat projects with similar applications exist. If a similar application is given, then you can say that last time it took 28 person months. A similar assignment, I am sure I can do it in 24 person months or 28 person. That means I can repeat at least that process. Level 3 is a defined process. That means for management and engineering activities, the process is standardized, documented and integrated across the organization. Coding. You have to code, let's say Java code. So Java coding standards are documented and they are made available to every programmer. And no programmer is permitted to write a code which does not measure up to those programming standards. As I said, variable naming. So COBOL programming language permits variable name up to 31 characters long. It also permits name of one character. But if you go to Tata Consultancy Services, there might be a COBOL coding handbook which says every variable name must be minimally 15 characters long. Now that's a rule. You might say it looks stupid to me. But if you write a 5-character long variable name, you lose your job. As simple as that. Because that's a management process, defined. You will understand that is why we call it engineering. Engineering discipline has to be like that. Of course, it does not mean that there is no scope for innovation or modification or something. There is enough scope even within the engineering defined boundaries for doing innovation. But this is what CMM level 3. Yeah.
How they categorize that this belongs to the CMM level 1 or 2 or 3?
There are processes. For example, I used to go as an auditor. So the external agency, Indian Registrar of Shipping used to be an external agency for ISO certificate. You are familiar with ISO? ISO 9001, etc. What is ISO 9001? ISO 9001 or ISO certification is about repeatability of a quality. It is not about good quality. So for example, if I guarantee that I will produce, let's say, a life jacket made of concrete, and the functionality I guarantee that it will sink in the sea. As a life jacket is not good quality. But if I guarantee that 1 million life jackets I make, each one of them will sink exactly in the same time, they still have ISO certified product. Of course, ISO does not say that you should specify such stupid thing. But what I am saying is ISO is about repeatability. If I have said this, then anything that I produce will be within this variation, is what ISO is about. CMM level says that if you are at level 1, you are here. If you are at level 2, you are here. If you are level 3, you are here. If you are level 4, you are here. Level 5, for example, defines optimizing level. Not only processes are all documented, followed, but quantitative feedback exists from process for continuous process improvement. The documented process itself undergoes changes based on the feedback that you have received on certain projects. The level 5 permits testing innovative ideas and technologies. Now, the first level 5 authentication of what you call audited thing was for an Indian company in the world. The maximum number of CMM level 5 software companies exists in India today. This fact is not very well known. Please understand that the rest of the world is not coming to India merely for cost arbitrage, as is made out in the newspapers. Here it costs less money, there it costs more money. Of course, that is one of the considerations. Anybody wanting to get software developed will try to do it at the lowest possible cost. But cost alone is never a consideration in these matters. The cost is considered useful if I get the same or better quality. Otherwise, the cost is meaningless. What is the point in saying at 1/10 cost I will develop the software, but it will never work in its lifetime? You would have wasted your time, effort, and even that 1/10 cost. So please remember that the nation is acknowledged today to provide the kind of quality that the world demands, and additionally, it is less expensive. So that's the way any society or nation has to build engineering companies. We should be proud of the software companies that we have here in the country. Okay. Now we will quickly look at the classical analysis modeling. Data object description. You are familiar with ER model. You have done some kind of modeling last time. You use the relational model. And process specification. How data is to be manipulated. That is done by what is called a data flow diagram. The first part we will not spend too much time. There are some slides repeated for your benefit. The third part is control specification. Okay, this is a data flow. Like registration should flow from this point to this point, this point to this point. Finally, you get, let's say, roll less. But should registration start flowing arbitrarily? Not without people paying their fees. Should registration flow throughout the semester? No. If the end date is 14th January or something, no further registration. Now these are control points. The control points define what can be done when and what cannot be done when. Or if something is done, what is the impact? How does the state change when some event happens? Consequently, most of the control specifications are depicted through what we call state transition diagrams. Some of you might have studied state transition diagrams because that's also a neat mathematical model. But that is a specification which is required to be made in any functionality to be achieved by software. Ordinarily, people are familiar with the data object description, which is a static description of data. Data flow diagram is the dynamic description of how the data flows and how it is processed. And finally, the control specification. These three are sort of orthogonal specifications. All the three together define your functionality. Okay. So in some way or the other, all these three must be captured in your system requirement specification document. Agreed? We have seen, first of all, representing information domain of the problem. You remember in the very first lecture, I had described 5 W's and 1 H. What, where, 5 wives and 1 husband was the nomenclature that is unfortunately used. But the H is how, and what you have to answer before that H is what information is required, where it is required, by whom it is required, when it is required. These are some very fundamental questions, and I will repeat what I said at that time. Generally, we don't ask all these questions when a problem is specified. Somebody says, write a program or subroutine for doing matrix inversion. We actually start writing program. What is going to be the largest size of the matrix? Who requires matrix inversion? What kind of matrix will I get? Will I get a sparse matrix? Why the hell you want matrix inversion? If you want to do something else, you want to calculate eigenvalues, I might have a trick to do that without doing matrix inversion. All these questions need to be asked. These require us to think. And unfortunately, our educational process, obviously, not obviously, unfortunately, it often curbs thinking. It says, this is the book, this is the formula, this is the problem, apply this formula, get this. In information system, there is no formula. You have to ask these questions. And many people have to ask these questions to ensure that the group actually culls out all the information. It's a very, very fundamental step. Today in the second session, this is what you are going to do with the fellow who acts as an end user. You have to ask questions. What is required, why is required, where it is required, when it is required, who requires it, and then how it is to be done. These questions will get information which information domain which can be then represented. You understand software requirements at this stage then, and finally you specify software functions, interfaces, constraints. All of these form part of the software requirement specification document. For the static data, you have the entity model. You are all familiar with this, we need not waste time. For example, we eliminate multi-valued attributes, etc., etc. Identify primary key, whatever. You have all the entities that you require. You just look at the table representation as a sample, so you know what kind of values will typically occur there. You will set up relationships where you will have attributes for the relations, etc. You will put a table for relationships and figure out whether something else is required like grade and whatever. The ER model captures static characteristics, associations which can be one-to-one or one-to-many, many-to-one. Easy to map the structure to files or database schema. We have seen all of this. And this model does not cover dynamic features, workflow and interfaces. This is the bottom line. So while it does capture important information, and I repeat again, the information is not captured through those diagrams. Diagrams are merely tools to indicate to us the overall features. But along with each diagram there must be a data dictionary describing variety of things. So data dictionary for entity sets, which is a repository for all information about entities and associations. For each entity, the name of the entity, brief description, approximate number in the set. Student is an entity. How many students? 5,000 or 5 million might have a completely different repercussion on the way you will design. Frequency of changes that will occur. Does a student come in every day and goes out every day? Does the student population come in and leave in bulks? Yes, it does at the beginning of an academic year. Now, what is the impact that it has? Student coming in every day and going out every day actually is less load on the performance of the system. But if 600 students go out and 800 new people come, you need to process that very quickly. Today, in terms of this example, the processing is not much. But imagine when the peak load comes and when the number of things to be handled is say 3 million. Look at the Reliance IPO, for example, in the market. SEBI decides that within 10 days refunds must be made. The number of people who have applied for that is whatever 50 lakhs. Each of them has applied for 10 times what they are entitled for. 50 lakh refund orders must be printed, sent back to the end user. The banks must gear up to refund that money put from one account to another account. This is not a trivial requirement. So all such things must be captured right up front. And after all this, there is any other information which you may think of relevance. Then for attributes, there should be data dictionary entries. Typically, the entries are organized such as first entity entry, let's say 1 page or 2 pages, and then 5-10 pages of attribute entry, then next entity. But you will also summarize all entities in 1 or 2 pages, saying these are the major entities and these are the attribute, just the names, etc. For each attribute, the name of the attribute, brief description, data type, field width, valid values, what is the domain? Okay, like hostel, valid values are 1 to 30. And please note, it must be written during system analysis, because later on that document is going to somewhere else, and designer will just write the algorithm, and when the programmer writes program, if we have not specified this, if we have just said 2-digit number, you may end up getting a wrong entry of hostel number 38, which is just not valid. There is something else which I have not written here, constraints. You are already familiar with the notion of constraints when we define tables. The constraints must be mentioned here. This attribute value in this entity depends upon that particular entity being there somewhere else or that value being there. As many constraints as you can think of at this stage. There will be constraints at the design level which we will do later. We will very briefly discuss now the flow modeling. The flow modeling, we'll take one more tutorial on the flow modeling so that you will understand the concept better. But this is just to indicate what kind of questions you should ask during systems analysis phase, because this is what you will have to prepare ultimately. In flow modeling, as information flows through a system, it undergoes changes. It is called transformation. For example, first screen that you get on registration form is roll number, course. The moment this information goes inside, you know that it is going to be stored in multiple table or a rich table, etc., etc. You don't know that at the front end, but it has gone through transforming. When as a teacher I get a report which is generated by a query, I see a different screen altogether. So consequently, information is transforming as it gets into the system and as it goes out. And this transformation is done by programs or processes. So at what stage processing is done? For each process, what is the data that flows in? What is the output that flows out? Where does that output go? These are the things which are modeled through data flow model or data flow diagram. A transformation represents part of a system function which is called a process. So process is nothing but an algorithm which will work on incoming data and produce outgoing data. In short, ultimately, a process that is depicted in my analysis is likely to become a computer program. It is up to the designer to say that the entire functionality is implemented by a single program, or I will break it up into 20 programs, or I will combine 4 such bubbles and put them into a single program. That's a designer's choice. But during system analysis, you are actually saying how information flows in the manual system or in a semi-computerized system, and you will model that information flow and the processing. Such flow and the attendant transformation is captured using a model of data flow, which is called the data flow model, represented by data flow diagrams. So DFD is the term that is used. Here is an example of a data flow. This is a data flow for, let us say, enrollment of students, let's say attending our university scheme, affiliated colleges, and they are registering. Or you take your own registration system with some small variation. You are a participant in the course, you want to register for a course. You will fill up the registration form. The first process that must be executed is validation of registration form. Now, how will you validate the registration form? First of all, you validate whether that student exists or not. So there will be some enrollment master register in which you will check, yes, that student exists. Then you want to check whether the student has paid fees or not. There will be some account master that will be checked. There may be other validations that are required. For example, there may be a course master. Say, is he registering for the valid courses or this semester or whatever? Let's say this is not course registration, this is just registration for the semester. I will define my courses later. Even then these things have to be checked. If everything is okay, I will prepare what we call role list and give it to the teacher. If everything is not okay, we will produce an error list. Now this error list will have to be handled by someone. Maybe in my analysis, in my system function, I have allocated that job to a human being, a clerk to look at it. Maybe I have another automated process which reads this error list and then prints maybe different reports or throws back the registration or makes some corrections and put that registration back, anything. In short, these circles that you see, these are called bubbles. They are often represented by ellipses in modern diagrams. These are bubbles which represent process or algorithm. Validate registration is a process which will take the registration data, go and read this file, verify whether the student exists, go and read that file, verify whether the student has paid fees, goes and read other master data, are the courses part of the offered courses, go and read another file containing Senate rules saying minimum CPI this cannot be permitted, whatever, and will then produce this. So this is then, you can see that this is going to be a program ultimately. Now whether this is a single program or 5 different programs are written, we shall see how further analysis is done. But you agree that this flow is required? Notice that arrows indicate the way the data flows. What is the data flowing? The participant, the rectangular boxes are external entities, very obvious. Participant, faculty. What is flowing from participant to validate registration? There is an arrow which says reg form. What does it mean? Registration form. But you and I know it. Will a designer or software developer know that? No. What is reg form? For him there are exactly 7-8 characters. REG-FORM. Does not mean anything. Consequently, just as you have data dictionary for your entities, you must have data dictionary for each of the named arrow that you have. Reg form means these data items in this form, this width, this data, these values. You require a data dictionary for that, without which reg form contains no meaning. What does this arrow indicate? We said whether the student has paid the fees or not. Why did we say that? Well, we generally know that fact. Is this DFD adequate as a document? Most certainly not. There cannot be any arrow without a name associated with it, and there cannot be a name associated with an arrow unless the name is further expanded in a data dictionary entry. Now you can see why system requirement specification document will be very big. There is nothing left to understanding, common understanding. I know, you know that the student has to be checked for fees payment. Inadequate. In software engineering, the document must state what is it that this will take here, what is it that will bring it back, and what is it that this validate registration will do. This thing must be stated. Consequently, you will find that there must be some name, validate information, role list, DFD. There cannot be any diagram component which does not have an associated name, and every associated name must have detailed description of what it represents. You understand? So now when you model the functionality requirement, one is the static model and the other is the model of how the data flows. And you will have to prepare these diagrams. Okay. There are more repercussions of these diagrams. Let me just explain the basic DFD symbols. For example, I have a system which I am representing data flow for, which is, let us say, accepting donations from donors to IIT Bombay. Donors may give actual money, they may give a paper saying, I pledge to give you this much money next year. They may give money for this project or that project. They may give money by check, by this, whatever what. I want to represent all of this. I will have entities representing donor, account, whatever, and I will have workflow. Who approaches a donor? When does donor give something? What happens with the donations? How does one do accounting? Where receipts are printed? These are all flow related problems. I have used that to merely show you the basic symbols in a DFD. They are exactly 4 symbols. A rectangle specifies an external entity. An arrow specifies data flow. We have seen that. An arrow without an associated name is not permitted. Account statement is a statement flowing there. And of course, I must detail this account statement through a data dictionary entry. Check expense is the process. Each process must be named. How will this check expense will be described? It will not be described in a data dictionary entry. It will be described as a possible algorithm. So check expense for a particular donation means this fellow had given $1 million. Out of that $1 million, I spent so much money in a building. I built so much, I bought so much equipment. I put so much money in a fixed deposit. And from the annual interest earning of that, I am using that money to pay for travel of my research students or to pay for this staff, whatever what. All this will be described as a process. So this will have to be checked. Each of these checking may require creation of additional storage of information, some of which may result into additional entities which you did not envisage because those were not external entities. So you can see it's a huge iterative process. The last element is a data store. For example, pledge information. All people who make pledges are stored here. So let's say Nandan Nilekani made a pledge that in year 2010 he will give you, let's say, 1 crore rupees. Then that must be recorded. And what would be the associated process? A process which will run every month, saying read out all the pledges. Make out which are the pledges which are expected to mature during this month. Print letters signed by director. We are very happy to recall that you had made a pledge 2 years ago. Please pay. A letter to the Dean of Resource Mobilization says, we will ring up Nandan later on saying, by the way, I have not yet received your check. And if a pledge is fulfilled, then a feedback saying this pledge is fulfilled, please do not send reminders again. You see now the complications, and they all must be captured during the requirement phase itself. And many, if you forget, you will have to keep capturing them in a modified software. Okay. So these were the DFD symbols: external entity which is source or consumer of information. Arrow represents flow of data. Process describes transformation. Ultimately represents the algorithm of or program that gets or puts data from or to arrows and contains processing specification. The processing specifications technically are called P-specs. Ideally, you could just write an actual computer program for a P-spec and your software is ready. Unfortunately, it's not as simple as that, because you don't write software in that manner. There is a phase called design, and we shall see how during the design many of these processes might be merged or further split based on the design principles. But essentially you are capturing the complete crux of what is to be done, how it is to be done during the analysis phase. DFD Data Dictionary, each symbol must have an associated label. You understand why the label is important? Data dictionary entries must define that label in terms of its metadata. Process narrative or P-spec must be included for each process. And this is only this, when you do all this, you get a system requirement specification document. I will just show you. Okay, there is a level 0 DFD. No, I won't go through those details. Again, the book on software engineering contains, unfortunately nowadays they will emphasize only object-oriented analysis and design, but you will find some reference to these. In fact, on internet you should have enough material on data flow diagrams and so on. Okay, this is a Center for Distance Engineering Education Program System. This is called a context diagram or level 0 DFD. It has only one bubble, and the bubble does not have any processing specs. It is the name of the system. It captures all the major inputs to the system and all the major outputs from the system. For example, participant information, course information, faculty information, remote center information. What comes out is participant grades, course contents, annual revenue. I have just shown sample. There may be 25 arrows here and 30 arrows here. But this context diagram, you will agree, will in a nutshell give me a good grand picture of the system that I am trying to produce. So this context diagram is not truly a DFD. A DFD will come with all the process specs and so on. But you will agree that those process specs will nothing but multiple processes inside this, with some input going there, some output, individual output going to some other process, finally something coming. This is something you must query during your system requirement specification phase. What kind of user interface is required by your system? So I am telling you I want this software. What kind of screens do you want? What kind of data entry screens do you require? What kind of queries will you put? What menus do you require? If you want to produce reports, how should that report look like? For example, if as a teacher I say that you must give me a roll list, I will generally expect roll list to be sorted on roll numbers, so that I can easily cross-check how many students of each department, whatever. Any list or any report, in a financial report, you may want page totals to be written on every page. You may want sectional expenditure total written or departmental expenditure total written. All these are specifications of user interface, and they must be collected from the end user. If an end user is unable to give, saying that you generate this report, then you must write a format of the report, show the user saying, is this the way you want your report? And include that in your system analysis. So all user interfaces have to be defined and included during the system analysis phase. Now you see why that document will become very large. So what content should be there for reports, in what format, should they be shown only on screen, should they be printed, should they be printed on special prepared stationery, should they be printed on ordinary stationery? Any special interface that you want. You want a special interface saying that you shout at your screen saying yesterday later, and it should produce some yesterday later, something like voice command activation. Now this is a special interface. You may ultimately decide not to implement that system, but you want to capture the requirements. Screen and forms layout, source and target stores, operational considerations, how user can use it very easily. That's called user friendliness. Keystroke minimization. People should not have to type and retype the same thing again and again and again. Okay. And finally, this is the SRS document. I will leave this document here for you to read. Typically, a software requirement specification document will have an introduction, will have the basic functional specification of the overall system. Just 3 or 4 pages or 5 pages of that specification. Then it will have data models for ER model and data flow model and complete associated data dictionary. Then it will have user interface requirements for screens, menus, reports, everything. Then it will have interfaces to other systems. What could be the other systems? A video clip of Dr. Abdul Kalam is available for inaugurating the Golden Jubilee of IIT Bombay with some, let's say, estate office or something. Such clips may be available from 10 different sources. In my software, I want the ability to absorb these clips automatically. What format should those clips be in? How they will be transferred on a CD, floppy or a file transfer? Which directory these things will be stored? How will be the interface between those two systems? All that needs to be prescribed. Interfaces to any external system for the proposed software must be defined in the SRS document. Then procedures and workflow. Who will do what? You remember I said people's assignment. What jobs people will do. Which people will do what job needs to be defined here. Acceptance criteria. So he is the end user. You have to ask him that, okay, I developed this software. Now, how will you test it? According to us, you should test it by testing this. That's the acceptance criteria. That has to be defined upfront in the system requirement specification document. And of course, then you will have appendices, annexures, etc., given. Now you can see why that document could be a large document. Actually, I can tell you, if you do this exercise of reverse engineering, namely go back, take any program that you have written, any program, even a small program, and try to prepare an SRS document for that program. You will find that it takes more time to write the SRS document than it took you to write the program. But then, engineering methodology is what this is. And while you can get away with a single program because you are smart enough to write that program correctly and run it and get results, industry-grade software, large software cannot be produced in that fashion. That's the reason why you are softwaring. Procedures and workflow is in a system, let's say a Center for Distance Engineering Education program. Somebody is registering for that program. Now what is the procedure? The first procedure is to fill up an application form. Whose responsibility it is to make those application forms available? Who is the human interface? Which person you come and give the draft? To which person you make telephone calls? These are something which are beyond software. Which is the clerk who is required to execute a monthly report to be produced? Everything cannot be automated. In the workflow, what happens after what? For example, first somebody pays the fees, then only registration can be issued. Now this is a workflow. Somebody makes an application for dropping of a course. This must be approved by the department head. Then that must be approved by the dean. Without that, you cannot drop a course. You cannot change a course. Now these are procedures which are not part of software. Software does not know that dean has to approve after this. That is workflow. The dependencies of that workflow also need to be captured. So you are basically, when you say software requirement specification document, you are also stating under what workflow this software requirement specifications will be made by my software. These tasks will have to be done by these people. You might even have another automation system for electronic transfer of document. But even there, for example, when I apply for an advance of 10,000 rupees for a project from say my sponsored or consultancy project, it must be approved by head. If it is not approved by head, I cannot withdraw that money. Now that is a workflow which I have to define. How do you define a head? How do you define a dean? What is the human process involved? What is the procedure involved? All of these things need to be captured. You please remember, you are implementing an information system. An information flow is controlled by and is meant for people. So you must describe which people come at what stage, for which people, which jobs have to be done manually, which jobs are automated, at what, remember the control specifications we said? Where will control specifications be modeled? We have not seen state transition diagrams yet. But the specification for those controls or events and the corresponding activities that the events will generate will have to be stated somewhere. So those we state here as procedures and workflow with a generic term. Is that okay? Now, producing this document as an industry grade document is one of the deliverables by your groups in this course. And you will appreciate, I hope, what is the importance of such a document, right?